Welcome to the Uptime Wind Energy Podcast. I'm your host, Alan Hall, joined by my co-host, Joel Saxon. Today, we're joined by Jonathan Zalar, Managing Partner at Independent Wind Turbine Generator Consulting, or IWTG, with over a decade of experience at GE Renewable Energy, including roles in root cause analysis and systems engineering. Jonathan brings a deep industry knowledge to his consulting work. We'll discuss recent events that we have seen in the field, explore how his expertise is helping wind turbine owners optimize their assets, and tackle some industry challenges. Jonathan, welcome to the show.
Thanks for having me.
So you've been around looking at blades and turbines for the last several months, and we've been in contact a little bit about what you've been seeing. Maybe just give us a brief description of what's happened this summer in terms of blades and turbines.
A lot of customers are starting to realize that there's some bigger issues that are coming to a head. And the need to look more is becoming more apparent. So, just because you have an external crack and you're about to go repair, it doesn't mean you shouldn't maybe take a look inside, especially if it's easy to get to. I have a few customers that are finding internal cracks and needs to monitor some internal issues more and more. So relying just on drones is maybe not the best thing anymore.
Yeah, let's talk about that, because we're seeing a lot of internal cracks. The manufacturer doesn't seem to be important here. It seems to be universal. The crack situation. Operators don't really have tools to go do that themselves. And they've been using drone inspections forever. So are they interpreting drone inspections external? Once it looks good on the outside, it's probably good on the inside. And is that the right move?
In most cases, it probably is, but depending on the type of crack you have and potentially some history on the particular blades, you might want to start taking a look on the inside. And I think as the industry keeps going with the blade repairs, they're going to start finding that, some of these might have started on the inside versus the outside. I mean, historically, most of the stuff is starting on the outside. I mean, you got a lot of, the coating coming off, the small stuff that, Cat 1s that you can steal with later. But so you get Cat 4s and 5s, they started somewhere. And if you're not confident it was the outside, spend the extra money and look on the inside.
So someone like yourself who's got experience, like you have experience from GEs, right? So you've been around the block for the last 10 plus years of GE turbines. You understand them, you know them, you have manufacturing experience, you have the RCA experience. So someone like yourself going to help one of these operators be that extra bit of bandwidth that they need in engineering, it's priceless for them, because the knowledge that you bring is huge. So we're seeing, why I'm highlighting that is it's important in my mind for some of these operators to not just look to their internal teams to solve problems, right? What does it look like? I mean, for clients coming to you to solve these problems, is your book full? What does it look like?
It's pretty full. And, some of the problems I do have history with, if they're on a GE, something I worked on before, but no, there's new problems that are coming up, and that's kind of the part that's exciting for me. It's all right, hey, we got this at, a bunch of turbines. What is it? I'm well, I don't know for sure, but this is how I would address it. And then that's how I help, my customers talk to the OEM and kind of get to the point of all right, what's not so much what the root cause is, just how big is the LAT, list of affected turbines? The goal of the beginning of most RCAs is how bad is it? How much bleeding do I need to stop? And, that's usually where I spend most of my time initially. And then after that, it's all right, why did this happen? What do we need to do about it? What's the long-term solution?
Are a lot of the turbine issues we're having today because of the newness of the turbine or the length of the blades? There seems to be a lot of problems out there that are not super old, right? They're a year or two old. What is the driving factor in that?
My personal opinion, I think the industry as a whole went very fast in rotor size. It was, the market was driven for 18 to 24 month rotor size increases, right? And the OEMs were all right, how many parts can we reuse? Can it handle these more loads? And, maybe got too big too fast. I mean, that's not OEM specific or anything, but the industry went very fast in the last 10 years. And I think there's been multiple articles about all the OEMs slowing down a little bit, right? Reducing their number of rotors they're applying in the field now, right?
Yeah, they're definitely consolidating the number of models, I think, to recover a little bit and get a beat on how to handle these longer blades. So what are you seeing on these turbines that are less than 5 years old? What kind of defects, problems, serial defects are out there?
Like a lot of the blades ones, I think we talked about, there's been some issues on different OEMs with the manufacturing issues. Not too many huge design issues that I've seen. And then, bearings are a big issue too. Main bearings and pitch bearings, they're very expensive, right? Multiple OEMs are having different bearing issues. And, a lot of that could be back to what I said earlier, like how fast are you growing this rotor size? And are you actually understanding what these parts are going to be doing, especially long term?
Yeah, I mean, I think we've talked actually between the three of us just about pitch bearings, right? So the blades got longer, but the diameter of the root didn't in some cases. So you have the same kind of forces and pressures on that root diameter, but with further and further, basically the fulcrum of that lever arm moves further and further away and puts more and more pressure on that thing. But so it's hard to keep up with the design thing there. So bearings being a huge one. Do you see a sweeping fix for some of these bearing issues? Now, I'm saying we got pitch bearings, we got yaw bearings, we got main bearings. Main bearing seems to be a big one right now. Is there a fix for this, or is we going to be on some of these platforms that are having these issues? Are we going to be replacing these things every 2-3 years for their lifetime?
I mean, I don't think it's going to be as bad as 2 to 3 years. I think there are other suppliers that are looking at different answers to these problems, right? The pitch bearings, I think they're looking at a third, basically roller bearing, I believe, on the outside. The other bearing manufacturers are seeing, okay, hey, these bearings are not working right now. What else can we do, right? And you can't really increase the size of the bearings because you can't change the main shaft. You're not going to change the pillow block or the bed plate. So they're kind of limited in what they can do. So it's going to be a lot of, with strength of materials and different greases too. So there will be some fixes that come out. They're very limited in what they can do just from a real estate perspective on the current designs.
The issue comes about in terms of lifetime on bearings. And a lot of operators don't have a way to guess when they would need to replace bearings besides seeing parts fall out. And if I'm going to replace a bearing, what am I going to replace it with?
Right. Well, and even before that, if you can get an indication that this bearing is going to fail, and you can derate and maybe run it for a year and line up the cranes better, there's opportunities there too with analytics. So both. The grease thing's interesting. I've not heard of that, but that's definitely an indicator when you start losing coatings, as an example. So if you have that indication, you have higher vibration, and you have some other analytics that kind of package together all right, this bearing's got 18 months. So what are you going to do about it? Well, how many more 18-month bearings do I have at site? If I derate them, I get 24 months. That's a lever to play, right?
Yeah, for sure. Because, at some point in time, you have to look into the reality of crane availability and how can we put a campaign together and what's the most cost-effective way to do this.
John, do you have some advanced insights because you're on the other side, on the OEM side, and SCADA data where you had high-speed SCADA data and the operators typically do not, and now you're on the other side of this fence with the low-speed SCADA data. How do you leverage that data to your advantage where you can self-diagnose what's happening to a turbine maybe a little bit earlier than you otherwise would?
So that's one of the biggest learnings I've had since going out on my own is I thought data would be easier to get from the owners, and I was wrong, very wrong. It could take weeks or months to get 10 different channels of 10-minute data, if they even have all the channels I'm looking for. So it's been a learning curve. And now a lot of customers I work with do actually collect higher speed data than I was expecting. A lot of them use Pi, if you guys are familiar with it. And they do have 1 second, 5 second, 10-second data channels. Now, the number of channels are limited, so I've had to be creative in some of the analytics I'm looking at. But especially in issues that have just started, getting that higher speed data, looking at trip logs, that's really important. And it's a really good tool to figure out what's going on. So it takes me a longer time to do it than I used to at the OEM because we had all the data pretty much as fast as we wanted it. But there are still tools available to the owners to get the higher speed data for certain issues.
What are those tools, John?
This is definitely G specific. So it's called G Toolbox. It's what, is running the software at the site. And you can log into a turbine, you can set up a dynamic data recorder and pull high speed data anytime a certain fault happens. So you can set stuff up like that to, pull the millisecond data and start looking at it when you're seeing certain faults over and over again, or you're trying to hunt an issue down.
Because if you just decided to put that on record for a whole 100 turbine wind farm, you'd have so much data you wouldn't even be able to handle it. Right.
It probably, yeah. If the server would stop working, it'd be terrible.
Well, are you seeing operators put added systems on to get more data from the turbines? I've heard operators that are doing that in some instances. Is that becoming more common?
A lot of it's OPC tags, right? So like the Pi basically like scrapes the OPC tags as it's going through the network. I think a lot of customers are doing that. Some are using GE SCADA as an example or the OEM's version, but it does become expensive, right? Because, if you don't have an engineering team looking at this data, you're probably going to stop collecting it when you start getting those big checks, or if you have to pay those big checks, right? But then when you have an issue and you're like, oh man, I wish I had that, you're kind of like, should have kept that going, right? So it's a toss up. Like the bigger owners that have, 1,000 turbines plus, they all seem to have some sort of consistent data recording system for higher speed than 10 minutes.
Is that like a Bayes field or power factors or something, or is that on the other side of things? Are those companies more on like the performance analytics side, less than SCADA?
I don't know for sure. I'm assuming they're using something like Pi to pull the data to go do their analysis. I think they're added on. I don't think they're scraping the data, but I could be wrong.
Is that helping to drive some of these solutions and just having more data? Because it does seem like when you walk up to a wind site, and especially if it's got 100 turbines or more, and you talk to technicians, they will rattle off 5 issues, no sweat, that are like universal across the site. These turbines have X, Y, Z, but they don't really have a solution for it, and they don't really have a way to monitor it. They just see the after effect. Like, I have to do an MCE on these turbines because of this problem. Are we getting ahead of that now, or are there more tools in the toolbox? I know you guys at IWTG have some of that knowledge, but I mean, what do you tell your customers? You're one person doing a really great job for the industry. How do you help them help themselves?
Some of the issues do have analytics that like the OEMs provide. There's like, some catastrophic blade crack analytics. There's, I think, some on the root inserts as an example. In main bearing, right? Main bearings, they look at temperature and vibration. I mean, I think every OEM does that for main bearings, right? So there are some analytics that, the OEMs want to create because they also have, full service agreements. So they're also motivated to do that. But the problems that don't have them, there are opportunities for people like me, and I have 1 or 2 people helping me out that, if given the time and you have enough failures, like there's definitely analytics that can be developed. And, I've been working on a couple of things with one of my customers, but it's not something that's all right, you're going to send me 3 failures and 2 weeks of data. I'm going to have an analytic for you. It doesn't work that fast. So it's something that you have to be working with somebody over a period of time and have very accurate data on, failure dates, which blade actually failed, stuff like that.
Well, let's talk to the blade insert issue, because I hear that one a lot from pretty much every technician I ran into this summer. Blade inserts are loose in some of these blades. They're sometimes hard to detect until it's like really serious, and then they limit who can go up and down the towers even at that point. Are there ways to detect that early on so you can at least evaluate that issue?
From an analytics perspective, my understanding, it's still in development from the OEM. I first looked at it a little bit, and it's really tough because you're trying to catch something that's moving like this much on a pitch bearing, right? Because the interface between the pitch bearing and the blade. That's going to be tough to do. Now, there are third-party non-destructive testing options that I've seen as well, which if you're worried about population, that's not, it's probably a good way to go. I, I think if the owners would continue to work with GE and the OEMs on like getting the right data, understanding if it's a false positive, I think there could be something there over time, but it's all about getting the false positives back to the right people.
So there may be a solution coming up in the future, but right now, the visual inspection is the key to catching it early?
I think so. I don't know for sure. It seems I hear it, but I don't hear a lot of failures that are like confirmed. I hear a lot of people talking about it, but I'm not seeing a lot of actual failures.
Joel and I have seen a number of blades with that issue, and a lot of complaints coming back from the field about it, because it is hard to detect. I think that's the issue. Is the technicians say, "Oh, there is pitch bearing grease on the blade. I must have a seal issue. I need to go up and look." And that's the real first indicator is grease on the hub.
Yeah, one of the companies working on is We4C over in the Netherlands, and Ado Kuipers from over there. He says when you're doing inspections of the nacelle or inspections of the blades, if you're up there, peel back the sealant a bit where the blade root meets the bearing face. And if you peel that sealant back and there's a gap there, then more than likely you have an issue. And you know, it could be, look here, look at the top. But if the blade is 90 degrees east-west, then you look at the top and see if it's actually peeling out that way. And you can see then that if there's an air gap there, if you can see through it, then you more than likely have an issue.
Yeah, and Meyer saying some of the other inspection techniques, if it does get flagged as a potential failure, it takes some time to do. It's some dial indicators and some movement of the rotor and the blade. So that might have been where those technicians were complaining, because I think the turbine's down for like a half day trying to figure it out.
Yeah, right, exactly. So that kind of leads to a little bit of a broader question. It's almost fall, right? We're beginning of September. It's going to get cold, and then inspections pretty much stop in the next month or so. What should operators be doing now to carry their turbines through the wintertime? What things should they be looking at? What things should they be watching out for? What have you seen?
Hopefully everyone's through their, second quarter inspections. If not, you better make sure you better go do those. And then, I mean, really prioritize the Cat 5s, Cat 4s. Be cautious on temporary repairs. If you're going to repair it, go repair it. I've seen some temporary repairs recently that have failed, and that just adds to the problem. Yeah.
Okay. I've seen some of those temporary repairs that looked to be severe. Cat 5 is the one I remember seeing earlier this year, and I thought, wow, is that going to make it?
Yeah, I mean, in the northern environments, northern climates, people do that just so they can get through the winter time, right? But sometimes it exacerbates the issue where you might be better off properly repairing it or using, some kind of. I know it's tough as the winter gets along and you're looking at what might be like a month-long repair or something. So there's this balance there, but I don't know. When they get water ingress in and all of a sudden you got to freaking open up, 6-8 meters of the blade to get it proper in the springtime, you might have been better off to properly repair it and spend a little bit more money that fall.
And I'm saying this from a technical perspective. I'm not looking at from an owner's revenue perspective either. So take that with a grain of salt.
Yeah, and what other things should they be looking at to kind of triage before the wintertime hits?
I mean, I kind of touched on a little bit about internal inspections. I feel I don't think every blade needs to have 100% internal inspections. I think doing some sampling of some Cat 5s might not be a bad idea.
Yeah, I mean, what we've looked at in the past from my wind blade experiences is it's a good idea to do like 10% of your fleet, 10 to 20% of your fleet. And then if you start to see something, or then expand the scope and then look a little bit deeper. Now there's specific models where we know of issues, right? We know where there's some cracking issues or some flashover issues in specific ones. And then it's smarter to do, a higher percentage of the fleet or all of the fleet in some cases. But at a minimum, they should be looking at a small percentage and kind of triaging it after that.
Well, John, what defects that they've stumbled across during the summertime would really force them to do 100% inspection?
I mean, something that's, at a location on the blade that is going to lead to a catastrophic failure. I mean, if you start seeing something like that, then that's when you throw the red flag in and be like, all right, we need to make sure we're safe here. When it starts becoming a safety risk.
Well, let me ask the one I've seen, because I think you've probably seen the same thing, where you see cracks in the hub on some more recent blades. If that has happened on a site, is that indicative of there may be more on the site that have that issue, and maybe internal inspections are required sooner, like 100%?
You just crack on the hub, like you mean the casting?
Well, not well. The hub itself, yes. I mean, we've seen cracked in hubs, but cracked at the base of the blade that have propagated. I've seen some of that this year just driving around in the Midwest, and then the cracked hub, which is the subsequent. I think that's subsequent, where they crack the casting of the hub. Does that then drive you into 100% inspection because it's such a severe failure mode?
I mean, it is a very expensive failure mode. I believe there's already a standard inspection a few months or whatever. I believe that particular issue is being handled with like a routine inspection, is my understanding.
But anything blade wise, it's probably like this is me pulling a number out, right? If you're basically from root to max chord and maybe another 30% of the blade or 40% of the blade length, if there's something that you're seeing within there, then you should address it before you let it just sit and run.
Yeah, root to max chord, that's, something cracks there and liberates, turbine's going to fall over.
This is where IWTG comes in, because I know there's a lot of operators that, as Joel mentioned, are really understaffed, and they don't have the bodies to throw at some of these problems, especially if they're unique, and to bring you in to take a look at what's happening on a site so that they can plan ahead. Because I think you're right. Crane, operators, power generation, all those factors come into play. And the first piece of information they need is, how severe is it? And do I really need, how cautious should I be? That's where they don't have an answer for. And that's why, John, they bring you in.
Yeah, understanding the risk is very important. And then understanding the LAT, like number of turbines this is on. Those are very important factors.
Can we talk about serial defects for a minute? Because I think this is, I'm seeing what I think are serial defects. And operators have, well, there's been one operator in particular that had his screaming serial defect. Others are sort of following that parade and joining in on it at times. Are we seeing more serial defect from the manufacturing side that's causing everybody to have more work out in the field on maintaining the turbines? And what is that? What is your feeling on what's driving manufacturing issues that are sort of plaguing some of the turbines at the minute?
Yeah, I'm not too sure about the serial defect part, because it's really tough to. And contracts are very different in what a definition of a serial defect is. And that's not my expertise. Your other question of why are we seeing this now? I mean, the volume of turbines have increased. The speed of design was increased. Then you had 2 years of COVID manufacturing, which you can't put numbers on or calculate that effect. Design tools have been slower than rotor size increases, as an example. I think a lot of those things are just kind of coming together for multiple OEMs at some really bad times.
So then do you look to see when your blade was manufactured, it was, March of 2020 through basically March of 22. Do you then pay more attention to those series of blades?
Depending on the defect, yeah. Like I said earlier, you really want to reduce the number of turbines by whatever problem you have. So from a blade perspective, you look at manufacturing location, manufacturing dates, serial numbers, mold lines, core kits, different materials used. I mean, that's where it's hard to get that information. It's not usually easily available, but that's where I try to help push my customers, is getting that information to say, all right, I have a 20 turbine problem versus a 200 turbine problem. Completely changes what you're going to do.
Okay. So that's where a lot of operators do not dig into. In my opinion, they're not looking at molds. They're not looking at manufacturing dates, so to speak. They're looking at blade types and trying to address it and coming from different manufacturing facilities. So is there a difference if a blade is made in Europe versus the factory in the United States? Are they just not the same thing? And yet we do treat them as the same.
Now, I'm not a materials expert, but there are definitely material restrictions depending on the country. Like different resins are approved here and different balsa suppliers are used in different places. So there is, if you're coming from 5 different countries, the blades are not exactly the same.
Is the arrow shape the same? I've seen a particular OEM that uses multiple manufacturers, and the arrow shape is not exactly the same, and the lightning protection system's not the same, even though the basic fundamental is there.
Drain holes in different places, all kinds of stuff.
So you guys did a build to spec, build to print episode, right? And walk through the difference between the two. So like in GE's case, they had a built to spec and a built to print blade. So the built to print blade is the one they have manufactured at TPI, for example. But they also have a built to spec blade, which was basically the blade needs to weigh this much, needs to have this arrow shape, use this many bolts, be this wide at the root. And that was what, they used LM for, because LM, this is before GE purchased them. Like LM would design the blade themselves and they would meet that arrow shape, number of bolts, stuff like that, so it fit. And then they would have, very similar performance, not exactly the same, but 2 different designs and 2 different materials.
When you're digging into blade issues, as particularly at some of these 100+ wind turbine farms, you need to know all the way down what that particular blade is, right? When it was made, where it was made, even down to the molds, because that'll tell you a lot about where this problem may be on other blades in your site, right?
Not every issue is going to be mold to mold specific, but that's just an example of getting down to that level of information can help you understand your problem.
So it really depends on, it can be the team that was working on it, right? But we're diving down into a lot of these details: manufacturer, location, possible, materials or consumables restrictions, down into the shift level. But what that all says to me is, if you have limited bandwidth in engineering, you have an issue, you need to grab someone from the outside to help you. You need to grab a consultant.
Well, John, it's been great to connect again, because you've been out in the field like us over the summertime. You've seen a lot of things, and you're a huge resource to operators that use you in the U.S. And Joel and I have met a number of them, and they love having you come in and diagnose their problems. So how do people get a hold of IWTG?
They can reach out to me directly with email, jzalar, ZALAR, at IWTGconsulting.com.
And the website is?
www.IWTGconsulting.com.
Well, thanks, John, for being on the program. Really enjoy having you.
Thanks for having me. I really enjoyed talking to you guys.